network analysis tutorial. In this tutorial, we work some problems on source transformation. This is the statement of problem under source transformation topic. Given practical voltage source with 20 volts and internal resistance 5 ohm, you have to find the current source. So this is the current source in which we have to find the current given Rs 5 ohm. So use the relation I is equal to V by R. Given V and source resistance, use this relation I is equal to V by R so that we'll get 4 ohms, current as 4 ohms. So now you write here the current source, and along with across the current source you write 5 ohm. That represent V to I transformation. In a similar way, the second problem will be like this. Given current source, you have to transfer this to voltage source. Note down these important points here. Current of 50 ampere is flowing. So here the resistance, source resistance is 10 ohm. Use equation V is equal to IR in order to find the voltage here. So after finding voltage, V is equal to 50 into 10, that is 500 volts. Write the Rs in series with the voltage source as shown. This is the third type of problem under source transformation. You have to find current through 1 kilo ohm resistor. Observe here this circuit. We have only voltage sources in series with the resistances. So we'll consider these resistance as the internal resistance connected in series with this voltage source. So when voltage sources are in series, we can add depending on the polarity. When current sources are in parallel, we can add or subtract depending on the polarity of flowing of current. On observing this circuit or network that is given, here we are able to find 6 volts is in parallel with 3 volts. So we cannot add 8 volts and 6 volts are in parallel, we cannot add. Therefore, convert these voltage sources into current source by using equation I is equal to V by R. What are the parameters given? Voltage source is given and internal resistance is given. Therefore, converting this into current source, that is nothing but I is equal to V by R. 6 by 2 is nothing but 3 ampere in parallel with the 2 ohm resistance. Similarly, this 3 volts is to be converted into current source. 3 by 1 amp, that is ohm, is nothing but 3 ampere in parallel with 1 ohm resistance. In a similar way, transform these two voltage sources into current source. So 8 by 2 ohm is nothing but 4 amperes, 6 by 1 is nothing but 6 ampere. Write the corresponding resistance across the current source. We observe here in this diagram the current sources are in series. Therefore, now we are going to see here the current sources are in parallel, here the current sources are in parallel. Therefore, since the current direction here in both branches are same, we can add. So on adding 3 plus 3 is 6 ampere, and these two resistance are in parallel, we have written here. Similarly, the direction of these two current sources are in same direction. Therefore, we can add 6 plus 4 is 10 ampere. And the two resistance are in parallel. Here it is written. Since these two current sources are in series, we cannot add. So let us convert these two current sources into voltage source. Therefore, we can convert the 6 ampere 2 ohm parallel with 1 ohm into a voltage source and 10 ampere 2 ohm parallel with 1 ohm into a voltage source by retaining the load resistance unchanged. This is the basic concept. When two resistors are in parallel, effective resistance is given by their product by sum. Therefore, here this resistance 2 ohm in parallel with 1 ohm is represented by 2 by 3. So what is the voltage I have to write here? It is nothing but I into R. V is equal to I into R. So I here is 6 ohm. So 6 into effective resistance is 2 by 3. 3 2s are 6. Therefore, we are going to get voltage 4 ohm. At the same time, the second voltage source we are going to get here is 10 ampere multiplied by 2 by 3 yields 6.66 volts. So now we can add these two voltage sources which are in series, and these two resistance are in series, we can add. Therefore, the circuit results with 10.66 volts in series with 4 by 3 ohm. Now use equation I is equal to V by R. We know what is V, we know what is R. So 10.66 by 1 kilo ohm is in series with 4 by 3 ohm. So compared to 1 kilo ohm, 4 by 3 is negligible. Therefore, this value can be taken as 1 kilo ohm. Therefore, current flowing through this resistance, that is 1 kilo ohm, is 10.66 milliamperes. In a similar way, you try to find the current through 5 ohm resistance using source transformation. Here, observe this network that is given. It consists of current source as well as voltage source. So we have to convert this voltage source into current source and find the effective resistance that is connected with the current source. Convert current source again into voltage source. You add the two resistance which is in series, convert that into current source, and then find the effective current that is flowing through this 5 ohm resistance. So this problem is given as assignment. Thank you. Happy learning.